One of the 6 roots of a complex number is given. We want to find the other roots. For a given complex number like z, if we are finding the nth root, we know that if I want to find z to the 1 over n on nth root, we are going to have exactly n distinct complex numbers. And they are r to the 1nth, e to the 2, k pi plus theta over n times I, where r is mod z and theta is arc z. And k can start from 0 to n minus 1 or from 1 to n, but we need to start from a point and continue up to the nth. So we find nth root of a complex number by this method. Now, one of these nth root is given, and it is here. So let's see what's the relation between the modulo of nth root and z itself. So here we can see that this is the modulo of nth root. It means that mod z is equal to mod, let's say z, k, any of those nth roots to the nth power, and arg z is n times arg zk, if zk is one of these nth roots. Now, since we have one of them, and the one which is given is 1 minus I, real part is 1, imaginary part minus 1, so it is somewhere here. Now we can see that arg z1 is at this point exactly on the line y equal negative x, which is 45 degrees below x-axis, so this is negative pi over 4. And mod z1 is root a squared plus b squared. A is 1, b is minus 1, so it is 1 plus 1, which is root 2. Now I can find mod z and also arg z. However, I don't need to find z. So we have two different approaches. One, find z first by taking this 1 minus I to the 6th power, and then start to find 6 roots of that z. Or we just knew the relation between their mod and arg. We can continue the same way. So I will explain the next method also. Now for z that it's not given, we knew that mod z is this root 2 to the 6th power. Root 2 means 2 to the 1/2 to the 6, which is 2 to the 6 over 2 or 3, and that's 8. Mod is 8, and arg z is 6 times minus pi over 4, or it can be minus 3 pi over 2. However, when we are studying arg z, we show by capital A to show the smallest angle with respect to right hand side of the x-axis. But if we consider this minus 3 pi over 2, if I start from here, from x-axis, then we can see that from x-axis at this point up to here we have 1 pi over 2, which since it's in the negative direction is minus pi over 2, minus pi, minus 3 pi over 2. But we know that if the point is on this axis or here, we consider the arc to be pi over 2. So the point is, if I want to show by this sign, which is the smallest angle that can show the ray when we have that complex number from right hand side of the x-axis, now it is pi over 2. So for the z that we have one of the roots 1 minus I, arg z is pi over 2, and mod is 8. Now I can explain or rewrite z as 8 times e to the I power pi over 2, or I know that e to the I pi over 2 is cosine pi over 2 I sine pi over 2, cosine pi over 2 0, I sine pi over 2 1, so this is 8i. It means that z is somewhere on the y-axis. Let's say this is 8i. So z is here. And one of the 6 roots of z, which is z1, is somewhere here. So the rest also are going to have the same mod. It means that they are on the same circle with different angles, and those angles are coming from here. 2k pi plus pi over n, or the other angles. So if I want to find the rest of the zk's, for all zk's are going to be like this. Root 2 with the same mod as z1 has, e to the 2k pi plus pi over 2 divided by 6i. Or if I simplify, it is e to the 4k pi plus pi, or I can just write 4k plus 1 pi over 12i. So if I give different values for k, 0, 1, 2, 3, 4, and 5, so the arc for the other 5 roots that we are finding as 6 roots of z are going to be the other theta k are going to be, if k is 0, it is pi over 12. If k is 1, it is 5 pi over 12. If k is 2, it is 9 pi over 12. So we can see that how many pi over 12 or what angles we need on this circle to show the other 5 points. So we have 6 points on this circle. One of them is given, it is here with angle minus pi over 4. And I can find the others by putting different values or giving different values for k and finding the others. So in this case, if I draw the circle again, the same circle. So if I want to show all the roots, I paste it. Make it a little bit larger. Let's say this is a circle of radius root 2. Since I have pi over 12, it means that from 0 to pi should be divided into 12 parts, or each quadrant should be divided into 6 parts. So this should be divided into 6 parts, or I can divide by 2 first, and then each of these are going to be divided into another 3 parts. So this is pi over 12. So here we have pi over 12. 2 pi over 12, 3 pi over 12, which is pi over 4. This part also should be divided into 3 parts, 1, 2, 3. Again, once I divide by 2, another time each part into 3. And this one, 3. The same once we find the midpoint of this quadrant, and then each of them should be divided into 3 parts, 3 parts. Now, I'm counting these points, pi over 12. So one of those roots is here. If I want to show an argand diagram, one of them is here. The other one, 5 pi over 12. So this is 1, 2, 3, 4, 5. The other one is here. And then 9 pi over 12. 5, 6, 7, 8, 9. So the next one is here. Now if we continue by substituting different values for k, I found, but for 0, 1, 2, for 3 we have 13 pi over 12, and if I substitute 4 times 4, 16, 17 pi over 12, and finally 5, 21 pi over 12. So this was 1 pi over 12, 5 pi over 12, 9 pi over 12, 10, 11, 12, this is 13 pi over 12, 14, 15, 16, 17 pi over 12, 18, 19, 20, 21 pi over 12. And we can see that this 21 pi over 12 is exactly minus pi over 4. So these are the roots. So this is exactly 1 minus I. And we can find the algebraic form of the others. So these are 6 roots of z, and z was 8i. 1, 2, 3, 4, 5, 6. And if I want to find that z directly, we can see that this is we are done here. We found all the other roots. But if it says that z1 is 1 minus I, and we know that this is one of the 6 roots of z, then z is 1 minus I to the 6th power. If I simplify, I can write 1 minus I squared and then to the 3rd power. 1 minus I squared is 1 minus 2i plus I squared, which is another minus 1 cube. Minus 1 and 1 cancel out. We have 2i cube minus 2 cube minus 8. I cube is I times I squared, and we know that I squared is minus 1, so this is plus I, the same 8i that we had. Now another way is starting from this 8i and finding its 6 roots directly. It means that now I know that z has mod z is 8 because it's 8i. You can find its magnitude, it is 8. And arg z is pi over 2. And then we can continue similar way, starting with this formula. So if I want to find zk, I need to find this 8 to the 6th power. So if I want to find 8 to the 6th power, if you want to find zk, it's going to be r to the 1/6 and e to the I times 2k pi plus theta over 6. R is 8 to the 1/6, e to the 2k pi plus pi over 2 over 6 multiplied by I, and we know that 8 is 2 to the 3, 2 to the 3 to 1/6, it is 2 to the 1/2, and 2 to the 1/2 is root 2, e to the, and if we simplify this, it is 4k pi plus pi, or 4k plus 1 pi divided by 12i, the same as we did in the previous method. So we can do either way. Finding the z first and then starting from beginning and finding all 6 roots of that z, or doing this strategy that we did here and step by step find the other 6 roots and show them on the Argand diagram. But if we want to give the algebraic form, we need to simplify, and for each of these pi over 12, 5 pi over 12, we need to find sine and cosine if we want to continue to algebraic form. Now, for example, here we want to find the solutions of this equation and give them in algebraic form. This time we want to continue. So this is in exponential form. We left like this. But now we want to continue, as the question says, to algebraic form. Now, if this one wants to be equal 0, firstly I can factor from z. That becomes z4 plus 2i 0. Then z is 0, so this is one of the roots. Or z to the 4 plus 2i is 0, or z to the 4 is minus 2i. And from this one, we can see that z is minus 2i to the 1/4. It means that we need to find fourth root of minus 2i. So where is minus 2i? Minus 2i is somewhere on y-axis. This is 2, it is here. So this is minus 2i. Now we know that arc of this is minus pi over 2. So theta is minus pi over 2 for this minus 2i. And r is 2. We know that r is root x squared plus y squared. In this case, x is 0, 0 squared plus 2 squared, and it's exactly 2. Now, we want to continue and give all fourth root of this minus 2i. Now, the roots of this minus 2i fourth roots are 2 to the 1/4 times e to the 2k pi minus pi over 2 plus theta, but theta is minus pi over 2 divided by, since we are finding the fourth root, 4 times I. Or if I want to continue, this is fourth root of 2 e to the 4k e to the 4k minus 1 pi over 8. Now you need to know the sine and cosine of pi over 8 if you want to continue to algebraic form, or you can leave like cosine pi over 8. And k starts from 0, 1, 2, and 3 because we have 4 roots for this z. Now the solutions for this equation are 0, and if k is 0 from this one, then it is root 2. Let me write separately first. So let's say z, let's name this one z1. Let's say this is z1 equals 0. Because for this fifth degree equation, we have 5 roots. That's z1. So I name the second one z2. When k is 0, I have fourth root of 2 e to the minus pi over 8. And this is fourth root of 2 cosine minus pi over 8, which is the same cosine pi over 8. Sine minus pi over 8 is minus. So we have minus fourth root of 2 sine pi over 8 I. This is algebraic form. A number plus another, or real parts plus imaginary part times I. But what is cosine pi over 8 on sine pi over 8? If it is an angle that we can give directly, you can give the value like if it is pi over 4, pi over 3, pi over 6. Otherwise, you can leave like this. Then we can continue the same. Now, the other root is e to the, sorry, I missed I here. Here also I didn't write I. So if k is 1, it is 4 minus 1, so it is 3 pi over 8 e to the 3 pi over 8 I. And this is the same, fourth root of 2 cosine 3 pi over 8 plus fourth root of 2 sine 3 pi over 8 I. And we have 2 more roots, which is z 4. When k is 2, we have 7 pi over 8. I directly write fourth root of 2 cosine 7 pi over 8 and fourth root of 2 sine 7 pi over 8i, and finally the fifth root. So the equation was of degree 5 and we have exactly 5 different roots. One of them was 0 and the other 4 we found based on the fourth root of minus 2i. And this is fourth root of 2. If k is 3, we have 4 times 3 minus 1, 11 pi over 8 cosine 11 pi over 8 plus, again, fourth root of 2 sine 11 pi over 8 I. So these are 5 solutions for this equation. Equation of degree 5, z to the 5 plus 2i times z equal 0.